So we are going to work on section 5.5, which is solving rational equations. And first of all, we have to be able to identify a rational equation. That would simply be an equation that has one or more rational expressions that is in it. And so remember, a rational expression most typically is going to have a fraction with a variable in the denominator. And that's exactly what we're seeing in these examples right here. They're examples of rational equations. So to solve a rational equation, what we're going to do is first factor the denominators of all rational expressions. Then you're going to identify the LCD. Then here's what's different. We're going to use our LCD in another way or a different way. We're going to use it to clear the fractions. So the way we do that is we'll multiply both sides of the equation by that LCD. And this is what we're going to do to clear the fractions. What does that mean? It means the fractions are going to go away. And then we will just solve the resulting equation. So because a rational equation has a fraction with a variable in the denominator, we need to be concerned with any solutions that are going to cause that denominator to be a 0. Those could not be part of our solution. Okay. So I'm going to allow you to go back and look at this example at a later date if you need another example. What I'm going to do right now, because I think that's a lot to look at, let's just start fresh with this equation, okay? So the very first step that we're going to do is we are going to identify our LCD. So our least common denominator is X, because we only have one denominator there. This first X is over a 1. So, and then the 12 would be over 1 if you're trying to put them in fractions. So the only denominator that we have is that X. So second, we are going to clear the fractions. So the way you do that is you multiply all of your terms by that LCD. So it's going to be X times X, 32 over X times X, and 12 times X. So when we do that, we are left with X squared plus my X's reduce, and I've got 32 is equal to 12X. Now I'm going to go ahead and I am going to set my equation equal to 0. All right, so all I'm going to do is I am going to subtract 12X from both sides. So then I am left with X squared minus 12X plus 32 is equal to 0. So now we want to factor the left side. We're going to factor, and then we are going to set each factor equal to 0. That's applying the zero product rule. All right, so X squared minus 12X plus 32. I'm looking for what can I multiply that gives me 32 but adds to negative 12. Okay, so it multiplies, give me 32, adds to negative 12. So I'm thinking, well, 4 and 8 multiply to 32, but if I add them, I get a positive 12. But if I make both of them negative, a negative times a negative still gets me that positive 32, and it adds to a negative 12. So I've got X minus 4 x minus 8 is equal to 0. Set each of those factors equal to 0. X minus 4 equals 0. X minus 8 equals 0. So I've got x equals 4, x equals 8. I'm not done. I need to check the solutions in the original denominators. Okay, so I just go back to my original problem. The only denominator I have is that x. And so my only concern is that that x cannot be a 0. And I don't have that. My x, my solutions are 4 and 8. So those are good solutions. Oopsie. So my solution set is going to be x equals 4 and 8. There we go. All right, let's look at problem number 2. So for problem number 2, I start the same. I want to identify my LCD. So in order to do that, I would need to factor that x squared minus 9, and that's going to be x plus 3, x minus 3, because that was the difference of two squares. So now my least common denominator is going to be x plus 3, x minus 3. And I'm going to leave it in factored form. It's a little bit easier. So now what I want to do is I want to clear the fractions. So you clear the fractions by multiplying each term by the LCD. That's what we did before. That's what we're going to do again. So it's going to be x plus 3, x minus 3, x plus 3, x minus 3, and again, x plus 3, x minus 3. Let's go ahead and we're going to reduce. So my x plus 3's reduce. So I'm left with 4 times x minus 3 minus, okay? My x minus 3's reduce. So I'm left with 6 times x plus 3. Then my equal sign. My x plus 3 and my x minus 3's, they actually reduce. So now we're going to go ahead and we're just going to distribute that 4. So that's going to give us 4x minus 12 minus 6x minus 18 is equal to 4. So all we're going to do at this point is solve our equation. So we're going to combine on the left side, combine our like terms. And so we get negative 2x minus 30 equals 4. So the first thing that I want you to notice is this is not a quadratic. This is a linear equation. Remember, we learned how to identify the difference based on our largest exponent. So this one has an exponent of 1, which reminds us that we have a linear equation. So we just solve for x. There's no factoring involved. So I'm going to add 30 to both sides to get a negative 2x is equal to 34. I'm going to divide both sides by negative 2. And so x equals negative 17. When I go back to that original equation, I look at my denominators, and if I plug a negative 17 in to any of those x's, I am not going to get a 0. So that means that's a good solution. It checks out. All right, let's look at problem number 3. So for problem number 3, first thing I want to do is I want to identify my LCD. Remember, the first thing that I do is I do not want to create a situation where I have a common denominator. That's not what I'm doing. I'm looking at my LCD in order to clear the fractions out. And so in this case, I have a y as my denominator. That's going to be one of my factors. And then I have a y plus 1. That's my second factor. Okay? And so I'm going to multiply all 3 of those terms by that. So it's going to be y times y plus 1, y times y plus 1, y times y plus 1. Okay? So I can reduce by just taking with that the first terms there and reducing the y's. And so then I'm left with 16 times y plus 1. Then for my middle term there, I've got my y plus 1's reduced, and I get minus 16y. Next, my y's reduce, and I've got 2 times y plus 1. So now I just need to solve this. So I'm going to distribute, first on the left, distribute the 16. So I get 16y plus 16 minus 16y. Now on the right of my equal sign, I distribute that 2 and get 2y plus 2. So I'm going to go ahead and I see that on the left, 16y minus 16y is 0. So I've got 16 equals 2y plus 2. Subtract 2 from both sides. 14 equals 2y. Divide by 2, and I get 7 equals y. If I go back to check that with these denominators, it doesn't matter. Right here, I put the 7 in. Doesn't matter which denominator I put it in, the 7 into, I am not going to get a 0. So it's good. It's a good solution. All right, let's go ahead and let's do this next one. So I've got, first thing I want to do is I want to find my LCD. So my LCD for this problem is x minus 4, x plus 4. I'm going to multiply everything by that. Even this 1. And then the third one. I know it's a little squished in there. Okay, let's go ahead and reduce. So the x minus 4 is reduced. So on the left side of my equal sign, I have 7 times x plus 4. Then equals. Then I've got x minus 4, x plus 4 times 1. So that's just going to give me x minus 4, x plus 4. And then on my next term, my x plus 4 is reduced. So I've got plus 9 times x minus 4. All right. So now let's go through and simplify this. I'm going to start by distributing the 7 on the left. So I get 7x plus 28. Now, my friends right there, x minus 4, x plus 4, that is an example of a conjugate. A conjugate will always give you the difference of 2 squares. So it's going to give me x squared minus, because of difference, 16. And then I'm going to distribute the 9. So 9x minus 36. All right. So I can go ahead and combine the negative 16 and the negative 36 on the right. So I've got 7x plus 28 equals x squared. I'm going to put plus 9x and then minus 52. So now all I need to do is bring everything on the left over to the right. I'm going to set this equation equal to 0. So I'm going to subtract 7x, subtract 28. Subtract 7x, subtract 28. So I have equality on both sides. So I have 0 equals x squared plus 2x minus 80. All right, so that right here on the right, that trinomial is a quadratic because my largest exponent is a 2, and I can factor quadratics. So when I factor this one, it's going to be x plus 10, x minus 8. If I multiply 10 and negative 8, it gives me negative 80, and I add them, and it comes out to 2x. All right, so now I set both of those factors, x plus 10 equal to 0, and x minus 8 equal to 0. So x equals negative 10, x equals 8. When I put those back into my original problem, neither of those solutions create a 0 in the denominators. So they're both good solutions. Okay, let's do 5. 5 is going to be an example where we get no solution. And if you look at this problem, it looks like any other problem we've been doing. And we're going to approach it the same. So first thing we do is we take the quadratic in this third denominator and we factor it. So that's going to be x plus 5, x plus 6. Our least common denominator is going to be x plus 5, x plus 6. We multiply each of those terms by that least common denominator. All right, so x plus 5, x plus 6, x plus 5, x plus 6, x plus 5, x plus 6. Okay, let's go ahead and reduce. So looking at that first term over to the left, my x plus 6 is reduced, and I'm left with x, I don't even need the parentheses here. I'm just left with x plus 5, because x plus 5 times 1 is just x plus 5. Now my x plus 5's reduced, so I've got plus 4 times x plus 6. Now on the right side of my equation, my x plus 5's x plus 6 reduce, and it's equal to negative 1. Let's go ahead and distribute on the left, and then combine like terms. So I've got x plus 5 plus 4x plus 24 is equal to negative 1. So 1x plus 4x gives me 5x. 5 plus 24 gives me 29. I'm going to subtract 29 from both sides. So now I've got 5x equals negative 30. Divide by 5. X equals a negative 6. So I'm going to go ahead and I'm going to check my answer. Let's go to my my denominators, and let's start with this. I'm going to take the negative 6 and I'm going to input it into that first denominator. And so if I get negative 6 plus 6, that's 0. So that means this does not check. So there is no solution. Formulas involving rational expressions. Hang on one second. You have, it's going to tell you what you're solving for. So we're solving for R, okay? And so we are going to start this exactly how we've been doing all of these problems. We're going to clear the fractions and then use algebra to solve. So let's go ahead and look at this problem number 6. So one thing I want to note right here is that a capital variable and a lowercase variable are two different things. So in this particular example, we are being asked to solve for capital P. That means I want to get capital P all by itself. So let me just rewrite this problem. PV over capital T, all caps, equal to PV lowercase t. My LCD is going to be capital T lowercase t. And that's what I am going to multiply both of these problems by. Capital T, lowercase t, capital T, lowercase t. And so the first thing I've got here are my capital T's reduce. So then I've got capital P, V, lowercase t equals my T's. They cancel out. So I've got lowercase p, v, capital T. I'm still solving for a capital P. That's the only variable I have. The rest of them you have to consider as if they're constants. So anytime I've got a coefficient, which is what the V and the T are, I just divide both sides by that coefficient. That's what P is equal to. That is my answer. Okay, let's do another one. All right, this one, it's asking us to solve for A, and A is in the denominator. So, same thing as before. We are going to find our least common denominator, and that in this case is AB. So we're going to multiply everything, including the C, times that AB. So for our first term, the A's reduce, and we're left with B. B plus. Then my B's reduce, and I'm left with A. So on the left side of my equal sign, all of those fractions are gone. On the right side, I just have A, B, C. I need to still, it's asking me to solve for A. So I am going to subtract B from both sides. And so it's left with A equals A, B, C minus B. And so for this one, the problem is that I have an A over here and an A over here. That's a problem. Okay, so I want to get my A's all on the same side. And so I am going to subtract A, B, C from both sides. So now I've got A minus ABC equals a negative B. I can go ahead and take out my A. On the left, I'm going to go ahead and factor it out. So now I've got A times 1 minus BC equals negative B. divide both sides by 1 minus BC, and that is what my A equals. A is equal to negative B over 1 minus BC. Okay? All right. Let's go ahead and look at 8, because that last one was kind of tricky. Let's make some room here. All right, so this one, we are going to solve for R, and there's R, it's buried. So let's just rewrite this. I equals E over R, big R plus little r. Let's multiply both sides of the equation by R plus R, big R plus little r, big R plus little r, okay? So on the left, I'm going to be left with IR plus I little r equals E. Well, we're solving for little r. So I want to move this big R to the other side, and I do that by subtracting. So now I'm left with IR equals E minus IR. Divide both sides by I, capital I. Okay, so I am left with R equals E over IR. I'm sorry, E minus IR over I. Okay, last one, number 9. We're going to solve for B. So first thing I want to do is I want to get rid of all of these fractions. So I'm going to multiply everything by the least common denominator, which is A, B, C. So A, B, C, A, B, C, A, B, C. There we go. So now we're left with the A's reduce. So we've got BC plus the B's reduce. We've got AC equal. The C's reduce, and we've got AB. Okay. We want to solve for B. Problem is, I've got a B on both sides. So the way to do this is you've got to get your B's on one side. That's your first step. So I am going to subtract an AB from both sides. And so that's going to leave me with BC minus AB plus AC is equal to 0. Well, I don't need this AC. That needs to go back over to the right. So I'm now going to subtract AC from both sides. So that's going to give me BC minus AB equals a negative AC. We're going to take out a B. Okay, so we're going to take out a B, and that's our greatest common factor. So we got C minus A equals negative AC. So I am going to go ahead and divide both sides by that C minus A. So B is equal to negative AC over C minus A. Now, if you did it slightly different and you got AC over A minus C, these are exactly the same. Because remember that this C minus A is the same thing as -1 times A minus C. And that would cancel out the negatives. And that's how you get that positive. All right, we're going to end here. You'll do your homework, do fabulous. Email me if you have questions.